Assalamualaikum warahmatullahi wabarakatuh. My name is mmj10403 and I'm going to explain about question 1 and question 2 of the assignments. So, the question 1. A piston cylinder device whose piston is resting on a set of tops initially contains 3 kg of air of 200 kilopascal and 27 degrees Celsius. The mass of the piston is such that a pressure of 400 kPa is required to move it. Heat is now transferred to the air until its volume double. So the first question, A is the state the energy balance associated with this system. So energy balance, the total heat added Q to the system can be split into two parts. Q1 heat added during the isochoric process and the Q2 heat added during the isobaric process. So the formula energy balance is E in minus E out equals to E system. Q equals to Q1 plus Q2. Internal energy equals to Q minus W, and W equals to P2 times V1, and Q1 equals to MCV times with subtraction of T2 and T1, and Q2 is equals to MCP times with subtraction of T3 and T2. And the specific heat capacity CV and CP can be found from the air properties, and the temperature T2 and T3 are the temperature at the end of the isochoric and isobaric process respectively. So question number 2 is show the process on the PV diagram. So this is the PV diagram. So V1 for the question C, determine the final temperature of the air. So we use formula V1 equals to mRT1 over P1. Then we just substitute the formula, and we take R gas constant. R is equal to 0.287 times with mass and time with its temperature that has been convert to Kelvin and divided with the pressure 200 kilopascal. So the answer we get is 1.29 meter per cube. As we know, the question state that V3 is double V1, and we can directly get V3 by times with 2. And after that, we calculate the T1. We convert T1 to Kelvin, which is 300 Kelvin, and we use formula P1 times V1 over T1 equals to P3 times V3 equals over T3, and final temperature that we can get is T3 equals to P3 times V3 over P1 times V1 times with T1. So the final answer we get is 100 to 1200 Kelvin. And for question D, the question asks to find the work done by the air, and we can use the formula and directly substitute into the formula P2 times with V3 minus V2, and the answer we get is 516 kilojoule. And for the last question is determine the total heat transfer to air during this process. So we can get the value of this internal energy by looking at the table, and just substitute the formula, which is M equals to subtraction of U3 minus U1 plus with work done that we calculate on question D, and the final answer we get is 2674 kilojoule. We move on to the second question. Okay, second question, as long cylindrical steel rods P equals to 7,833 kilogram over cm cube and Cp 0.465 kilojoule over kg dot degree Celsius of 8 cm diameter are heat treated by drawing them at velocity of 2 meter per minute through an oven maintained at 900 degrees Celsius. If the rod enter oven at 30 degrees Celsius and leave at a mean temperature of 500 degrees Celsius, determine the rate of heat transfer of the root in the oven. We have been given the P 7,833 kilogram over cm cube, but we have to change cm meter per cube to meter cube, or else we can keep it as cm cube, but the other thing we have to change it to cm also, like velocity. And we get 7.833 times 10,000 times 10 power of 9 kg over m cube, and Cp is 0.465 kg over kj over kg. And the diameter we have to change it to meter, since we calculate this question in meter, and we use formula V equals to pi d squared, which is diameter, over 4 times with L. Pi time, and we substitute the formula, we substitute the value in the formula, and we get 0.01005 meter cube. And we use the formula M equals to PV to get them. And the answer, we get 78 million 721,678 million 721,650 kilogram, which is the mass. And we substitute in the formula Q in, which is mCp times with subtraction of T2 minus T1, and we get 17 billion 204,616,607.5 kilojoule. And the final answer, to determine the rate of heat transfer, so we divided with T, and we substitute the value, and the final answer that we can get is 286 times 10 power of 6 kilojoule per second, or as kilowatt. So that's all. Thank you.